In this video, I'll describe a model for classifying videos that does not make use of a recurrent net. I'll demonstrate it on the problem of identifying if a video contains tobacco content. The model is applicable anywhere that you have a set of objects but are only given labels at the set level, and also when you don't care about interdependencies between the objects. Okay, I'll get to the model in a second, but first, what you're seeing here are videos containing tobacco content that are sped up 20 times. Now, the model allows for certain inspection into its decision-making process. Here we're showing a frame that the model thinks contains the most tobacco content. And it sort of indicates how well it's working. And again, the model is trained on video level labels, and so it's learned how to assign that credit back to individual frames. Okay, so let's take a look at the model. So this is my diagram of the model. What you want to do is go from the video up to a logit for that video that then you can train with your cross entropy loss. Okay, so the model splits the video into frames, applies a CompNet to each frame, then a dense layer, and then reduces that to a logit for each frame. And so at this point, you could certainly apply a recurrent layer, a recurrent net to those logits, and then process them sequentially and have the final output be the logit that you're then going to predict whether the video contains that tobacco content or not. And that could handle variable length videos just as this model can. But it's less efficient than this model. So here what we do is sort of the simplest form of attention. A softmax is computed across all the logits. So that softmax, the little circles there, are a distribution over all of the frames in the video, giving higher weight to frames that had a larger logit or more positive logit. And then the weighted sum is taken. That's the little multiplication and addition. So the weighted sum across all the logits is taken, where the weight is the softmax value for each of them. And that gives you your final logit. And what this model allows it to do is that during backpropagation, the label for the entire video is the credit for that label is able to be assigned to specific frames, and that's learned during training. So you might have a long video that doesn't have mostly doesn't have examples of the positive class that you care about, but a few frames do, and it can assign that label to those frames and effectively ignore the other frames. Okay, so let me show you one more thing that you can do with this model and kind of inspecting into it a little bit further. What we're seeing here, and these are going by pretty quickly, so you may need to pause to inspect individual examples. What we're seeing here is a set of frames from different videos, and then the probability that each of those frames contains tobacco content. And how this is generated is a trained model is taken, and then before that weighted average or weighted sum is taken, you're going to take the logits for each frame, and then instead of doing that weighted sum, you're going to just pass them directly to a sigmoid, which will get the probability for each of the frames. And then that's what you're viewing here, and it seems to correlate well with tobacco content and ignoring frames that and low probability for frames that don't contain the tobacco content. Okay, so in terms of performance, the area under the ROC curve is 92%, and that's sort of hard to interpret. So to give a specific example, if you wanted a true positive rate of 95%, you'd have a false positive rate of 40%. And in our experiments, I was able to get it, the whole system was performed better if you took the added step of going in and labeling individual frames and then just training a frame level model. But that's a lot of extra work, and this model sort of demonstrates how well that you can do pretty well with just the video level labels. Okay, so the summary, this is an alternative to recurrent model. When you don't care about these long-term interdependencies, which is the case for the classifying problems I'm dealing with here. And I say long-term because short-term, really, you could merge together with some context. So you could take, 5 frames on either side of the current frame and merge them all into one, and that would give you some local context, and then still apply the model here. But longer term dependencies where, something happens at the beginning of the video, something else happens at the end, and both of those are important for making the classification, that still is not appropriate for this model. But yes, so given those constraints that you don't have those interdependencies, then this trains faster than, the recurrent model, and it can also, handle those larger, longer sequences, or equivalently a larger set in this case, than a recurrent model could. And then also, as I've demonstrated here with a couple examples, it allows you to inspect a little bit deeper than you could easily do with a recurrent layer to see what's going on and how it's making its decision. Okay, so that's it. Thank you for watching.